Which of the following represents the most stable conformation of methyl cyclohexane? So let's start by drawing methyl cyclohexane. So that is a cyclohexane ring, a 6 carbon atom ring from that hexane, and it has on one of those carbon atoms a methyl group, a CH3 substituent. And so if we are looking for the most stable conformation, we want to make sure that these are all actually cyclohexanes, and you might notice right away that D is not a ring. It's the Newman projection of some other hexane. It looks like just methyl hexane. So this is not a cyclohexane, so we will not consider D. Okay, and then if we're looking for the most stable conformation of methyl cyclohexane, we need to know something about the major conformers that we encounter for cyclohexane. So we have 2 conformations, and they are represented, one of them is here in A, and these are both another conformation. So A, if you really use your imagination, you've got this boat shape. So this is the boat conformer of cyclohexane. And if you use your imagination even more and picture a person lounging, maybe they're back here and their feet up, in this chair conformation. So this is a chair, and this is also a chair. So the first thing that we want to know is which one of these conformers is the more stable one. Is it the boat or is it the chair? So what we're going to do, I'm just going to quickly draw a Newman projection so we can see where we have eclipsed and staggered conformations. So I am going to look down this bond and this bond of the boat conformation. And what I will see is that, and I'm just going to draw the boat itself. So I'm going to see off of, if this is my front carbon atom, that I've got a bond going straight up to a carbon that happens to be attached to the other carbon. And then because it's tetrahedral, I should also have hydrogens at the correct angles off of there. Okay, and then if this is my back carbon atom, I've also got the bond to the carbon that's going straight up. So those are eclipsing. And then I've got, the bond to the hydrogens, and everything is eclipsed. And don't worry if you can't draw one of these Newman projections, and we've got the methyl group sticking off of that. But what we're looking for is the fact that this is the eclipsed conformation. So the boat is your less stable chair conformation. So what this means is when you see this term most stable, you're automatically thinking, I need a cyclohexane chair. So I'm going to need to take a look at these cyclohexane chair conformations. And so I am going to do the same thing drawing a Newman projection. So I'm going to look down this bond and this bond. And what I should see is that this is the fully staggered conformation. So if this is my front carbon atom on one side, this is my front carbon atom on the other side, I've got a bond to carbon going up, and it connects to the other side. And then I've also got bonds to hydrogen off of those. And then on this back carbon atom and this back carbon atom, they're connected by a CH2 that is pointing down. And then also off of this back carbon atom, I can see I have the methyl group angled down and then a hydrogen that's coming up. And on the other carbon atom, I just have 2 hydrogens. So the chair conformation itself is your staggered conformation. That's why this is more stable. And so that is one of our chair conformations. If we were to draw the other chair, and so this time I'm going to just very quickly draw this framework. So I've got hydrogens off of this front carbon atom. I think I flipped it over, but we will try to work with this. So I made this bond going down and it should have been up. So that means on that back carbon atom, the methyl would be going down because I've inadvertently flipped this over. Okay. All right. So accidentally flipped over. Flipped. That's okay. It is still the same molecule, so if you take that and turn it. So what we're going to see here is that this is still staggered, but the key interaction that I want you to notice is between this hydrogen and this methyl group. And they are 1,3 to each other on the ring. And this is known as a 1,3 diaxial interaction. And so that makes a substituent on an axial bond. So this is an axial substituent. This is going to interact with that hydrogen on the other side of the ring. So what's going to be preferable is to have your methyl group or any substituent on the equatorial bond. And that's because those equatorial bonds do not have any sort of eclipsing interaction, even across the ring, with any other substituents.